Good morning, everyone. So here is our lesson for today. Okay, we are focusing on end behavior. Okay, I know it says graphing polynomials up here, but with graphing polynomials, we are talking about end behavior. Okay, and what end behavior is it tells us where the graph begins and where the graph ends, right? We're not looking at the graph in between right now. We are just looking at where it starts and where it ends. Okay, so the first thing that we are going to do in order to find our end behaviors of graphs and of examples is we need to learn what a leading coefficient is and what a degree is. So before we can do anything, let's look at number one, right? And here we're looking to see if number one is in standard form. And if you remember, standard form is ax squared plus bx plus c, okay? And notice that in example one, we have higher exponents. And with standard form, what we really need to know is that we are going in descending order. So we need the term with the biggest exponent to go first. So if I am looking at number one, I see that I have an x to the fifth here. And that's my biggest exponent. So I know that that term needs to go first. So I'm going to go ahead and write negative 9x to the fifth minus 7x to the fourth plus 5x cubed. And here you can notice that my exponents are in descending order, meaning they're going from greatest to least. Okay? So before we do any end behavior, we need to make sure that our examples are in standard form. Okay? Then my next step is to talk about the leading coefficient. And we know that a coefficient is the number that becomes before any variable. So the number that becomes before any letter in an example. Okay? So that's a coefficient. But we want to look for our leading coefficient. And what a leading coefficient is it's the first term that we see. Okay, so in example one, the first term that we see is a negative 9. So that's what you're going to go ahead and put on your line. Okay. Now we need to go ahead and label our degree. And what I mean by degree is just the biggest exponent that you see in the example. Okay, and here the biggest exponent that I see is a 5. Okay, so that's how we are going to complete these first two, which is going to help us with our chart that you see down below. Going with number two, okay, we're on to number two. I notice that I am not in standard form here. So I'm going to go ahead and put this example into standard form. So I have 4x to the fifth, which is the correct first term. But then I need to switch my second two terms. And here, my exponents now go in descending order from greatest to least. Okay? And once we have done that, we can go ahead and label our leading coefficient, which we're here, we're just going to label it as LC. So this is leading coefficient, okay? And the leading coefficient that I see is my first number that I see in my example. So that's a 4. And my biggest exponent that I see is a 5. So my degree is a 5, okay? So that is what we're looking for when we do end behavior. What we're going to look at is our exponent and our leading coefficient, okay? Now we're going to go ahead and go down to this graph because this part's important, okay? Sorry for that flip. This part's important. So when we're talking about end behavior, like I said before, we're talking about where the graph starts and ends. But where the graph starts and ends depends on our degree. Depends on our degree and our leading coefficient, okay, and our sign of our leading coefficient. So when I have a positive leading coefficient and an even number, and what I mean by even is obviously just our even numbers, okay, when we read left to right. So same thing with graphs. So our graph is going to start up on our left. It's going to be facing up, and it's going to end facing up, okay? And an example of that, I'm going to do it in green, okay? And an example of that would look something like this, okay? Where our graph is facing up both times, okay? Now, when we have a negative coefficient and an even degree, my arrows are going to be facing down, both arrows. And what that looks like is, I'm going to do it in green, something like this, where both of our arrows of our graph are facing down, okay? Then we go from having a positive coefficient to an odd degree. An example of this would be 1, 3, 5, dot, 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 okay? And now we want to remember odd. There's two meanings to the word odd, and one could be like an odd number, and the other meaning of odd is like something that looks strange, right? Something that we're not familiar with. So when we remember odd, our graph is going to look a little weird. It's going to start one way and end a different way, okay? So when we have a positive leading coefficient and an odd degree, our term on the left, our sign on the left, or the starting point on our left is down, and the ending point is up. So an example of this would look something like this, where my first arrow on the left is pointing down, and my second arrow on the right is pointing up. Okay? And then when we have a negative coefficient and an odd degree, it's just going to do the opposite. So my first arrow is going to be pointing up, and my second arrow is going to be pointing down. Okay? And an example of this one would look like this. Okay, with my first arrow on the left facing up and my second arrow on the right facing down. Okay? All right, then you're going to flip on to the next page. You're going to need to make sure you don't lose this. I would write this down on a piece of paper because you're going to need this over and over and over again. Okay? That's super important. That is you're going to need this chart for every lesson from here on for the rest of the unit. Okay? So now we're going to do some practice on that. So let's look at example number 7. So the first thing I'm going to ask myself is if this is in standard form. And I see that my exponents go in descending order, so I know that it's in standard form. So from there, I'm just going to go ahead and label my leading coefficient. And here, the first number I see is 3. Okay? And then I'm going to find my degree. And my degree here is 2. Okay? Now, I can't go back, but I want you to go back to your notes that you just took on your chart. And when we have a positive leading coefficient and an even degree, both of our arrows are facing up. And that's all I want you to draw. So when it says describe the end behavior, I want you to label your leading and your leading coefficient and your degree, and then just go ahead and draw your arrows. We are not drawing anything, we're not connecting those arrows because that's graphing. Here we are just describing end behavior. Okay? Then we're going to bump down to number 9 just because it's on the screen. Okay, so I am in standard form. So the first thing I'm going to do is I'm going to notice my leading coefficient, and that's a positive 3. And here my degree is a 5. Okay, so go back to your chart. So if you need to go back and pause on that chart and take notes, you should do that. Okay, so I'm going back to my chart, and I see that my leading coefficient is positive, and my degree is odd. So my arrows will look like this. The left arrow starting down and the right arrow ending up. Okay, so that chart is really super important. Then we're going to go ahead and go down to numbers 8 and 10. So first thing I do is it's in standard form. Check, right? That's in standard form. So the next thing I do is I look for my leading coefficient. And in this example, my leading coefficient is -2. And the biggest degree that I see is a 3. So I go to my chart and I go on the top. I go to my leading coefficient is negative, and then my degree is odd. So my arrows will start up and end down. Okay, and that's all you're doing. You're not connecting anything. Same thing for example 10. We are in standard form already, so I can go ahead. I see that my leading coefficient is a -2, and my degree is a 4. Okay, so on my table, I go back to the table and I see that my leading coefficient is negative and my degree is even, so my arrows are both going to be facing down. They start down and end down. Okay, so this is super important for leading coefficient for end behavior. All right, so we are going to go ahead and pop down to number 11. Okay, and in order to graph, right, we are just working on end behavior, but in order to graph, right, we're going to learn graphing next lesson. You need to have points on your graph. We just can't make up imaginary lines and put them through any points. So in order to find points on our x-axis, we need to use the zero product property, okay? And what the zero product property is it's just setting all of my parentheses equal to 0. We've already learned this, okay? So I'm gonna go ahead and do the first one out. So the first thing I'm gonna do is I'm going to set this first parenthesis equal to 0, and then I'm gonna set the second one equal to 0, and the third one equal to 0. Okay, and from there, I'm just gonna solve. So the first one right here is a two-step equation. So the first thing I need to do is add 3 to both sides. Okay, so now I have 2x equals a positive 3. And then in order to get x by itself, I need to divide by 2. Okay, and my answer that's left is x equals 3 over 2. So you can go ahead and put that on your line here. Okay, so x equals 3 over 2. What we also want to do is write a point for when x equals 3 over 2. And I know that in my ordered pairs, my x always comes first. So I'm going to put 3 over 2 in here. And whenever we're finding x-intercepts, my y is always 0. Okay, so when we're using zero product property to find our x-intercepts, your y is always 0. All right, on to number 2. So on here, I am just going to, this is a one step, I just need to subtract 4 from each side. And it leaves me with x equals negative 4. So go ahead and put that on your line. Your x term always comes first, and when you're finding x-intercepts, your y is always 0. Okay, now with these two problems, this one and this one, we're looking here. Okay, we're looking at those two parentheses. Rather than doing the workout, if you see that your answer is just going to be the opposite of your sign, that's fine. Because if you see in our example, we had x plus 4. My answer was just x equals negative 4. So if you can see that, you can just go ahead and put the answer down. I don't need to see your work. So for this one right here, I see that x minus 1 equals 0. So I know that my answer is just going to be the opposite. So x equals 1, a positive 1. So once again, my 1 goes in my x, and my 0 and my y is always 0. Okay, so we're using the zero product property. Moving on to number 12. Now, this one is important. We see an x just hanging outside the parentheses. No matter what, you need to set that equal to 0. Everything needs to be set equal to 0. Okay, so I'm setting that x equal to 0. I'm setting 6x minus 3 equal to 0. And 2x plus 12 equals 0. And then I'm going to go ahead and solve. Now, for this example, you don't need to solve anything. That's just your answer because x is by itself. So down here, you're going to put x equals 0. Your x is going to fall into your x side, and y is always 0. So that point is 0, 0. Okay? Then, for the next two, it's just a two-step equation. So I'm adding 3 to both sides. And then I'm going to divide by 6, okay? And I'm left with x equals 3 over 6. And I know that x equals 3 over 6 reduced is x equals a half. Your half falls into your x place, and your y is always 0. Okay? Then we're going to do the same thing with the third parenthesis. We're just going to subtract 12 from both sides. So now we have 2x equals negative 12. And then we just need to divide by 2. Okay, and now we're left with x equals negative 12 over 2, and I know that negative 12 divided by 2 is just a negative 6. Okay, and that goes in my left side, my x value, and my y value is always just 0. Okay. All right, so that's how we use zero product property, and we use zero product property to find our x-intercepts so we can plot them on the graph. We're not doing that today, but that's how you need to find them, okay? So these points down here are super important. That's why I had you write them in ordered pairs. So when we graph, it'll be much easier for you, okay? I want you to go ahead and try numbers 1 through 4 right now. Same thing, this was the same thing as the first page. So you're gonna tell me the leading coefficient, the degree, and then you're gonna go ahead and give me what the arrows look like. So please pause this video and go ahead and do those on your own. When you're done, press play and you will see the answers. So go ahead and pause. Okay, now that you're back, we're gonna go ahead and go over our answers. So when I'm looking at number 1, my leading coefficient is a 1, okay? It's never x. So if you put x for these, go ahead, pause this video, redo them, and then come back, okay? So my leading coefficient was 1, and my degree was 4. So when I have a positive leading coefficient and an even degree, my arrows will look like so. Okay? On number 2, my leading coefficient is 1, my degree is 3, and when I have a positive coefficient and an odd degree, my first arrow on the left is down, and my second arrow ending is up. Okay? Then I go ahead down to number 3. My leading coefficient is a -1, and my degree is a 5. So when I have a negative leading coefficient and an odd degree, my first arrow starts up, and my second arrow ends down. And then the last one, I have a -1 as the leading coefficient and a 4. So I have a negative coefficient and an even degree, so both of my arrows are facing down. Okay? Now, for numbers 5, 6, 7, and 8, this wasn't on your first page. This is new also, okay? What we need to do for 5, 6, 7, and 8 is find the y-intercept of each polynomial. Now, finding the y-intercept for polynomials is super easy, okay? All we need to do is look at the last number, so before the equal sign, so pretend that's not there. We're gonna look at the last number that we see with no variable, and that is our y-intercept. So when we're looking at number 5, the last number I see is a positive 5. So y is equal to 5. Okay? Now we are going to find our y-intercept, and we know that in our ordered pair it's x comma y. So now our x is going to be 0, and our number will be our y. So now we're flip-flopping them from what we saw before. Okay? So same thing on number 6. I'm looking for the last number with no variable. And in that case, it was a -10. So my y is equal to -10. And then I have 0, -10. Okay? So what I want you to do right now is go ahead and try these 2 problems. Okay? I forgot to write the line, so just go ahead and do that yourself. Okay? So pause this video and then come back for the answers. Okay, now that you're back, my y-intercept for this number 7 is -27, and that will be 0, -27. And for number 8, it's -9, and it's 0, -9. Now, what is important about a y-intercept is that if there is no number, no constant number, so that means a number without a variable, right? That's what a constant is. Then your y-intercept is always 0. So say you had the example y equals x squared plus 5x. There is no term here without a variable. So my y-intercept would just be 0, which would make the point 0, 0. Okay, so that's an extra example that you should write down on your paper. Okay, when there is no constant or no number or no term without a variable, then it's always 0. Okay? For numbers 9 and 10, I want you to go ahead, pause this video, and do them on your own. Okay? This is just like what we did on the first page. This is using the 0 product property. Okay? Setting everything equal to 0 and solving. When you're done, you're going to come back, and I'm just going to give you the answers. Okay? So please pause this video, take your time, do that work, and then go ahead and come back. All right, now that you're back, I'm going to go ahead and write the answers down. So when I'm looking here for my x-intercept, I'm looking at my first parenthesis. I see that this was a -7, so my answer is just going to be a +7. And my ordered pair will be 7, 0. Then I'm going to look at my second parenthesis. I know that this is a +2, so my answer is just going to be -2. And then my ordered pair will be -2, 0. Now for this one, you needed to set this up to 4x minus 5 equals 0. And your answer should have been 5 over 4. And your point would have been 5 over 4, comma 0. Okay? Now for the next one, I see that I just had an x, and every time that I just have an x floating around over there, I know that it's just 0. So my points would have been 0, comma 0. Then in my next parenthesis, I see x plus 9, so I see a positive 9, and I know that when I see that positive 9, my answer is just a negative 9. And it would be negative 9, comma 0. Okay, and then that last one, we're just looking at x minus 2, take the opposite, so x equals positive 2, and it's 2, comma 0. Okay? Now for number 11, what I want you to do is pause this video, and you're just going to write the examples in standard form, and then list their leading coefficient and their degree. Okay, so SF means standard form. So go ahead, pause this video, and come back when you're done for the answers. Okay, now that you're back, number 11 was already in standard form, so we really didn't have to do much to it. I'm just going to rewrite it so you can see. Okay, and then here, my leading coefficient was a negative 3, and my degree was a 4. Okay, and that's all we were listing there. Now, number 12 was not in standard form, so it needed to be put in standard form, and standard form would read negative 2x to the 6th plus 6x squared minus 8x, okay? And that's in standard form, where my leading coefficient is a negative 2, and my degree is a 6, okay? So that is all for today. You don't have homework. This lesson was just super important, and that chart on the first page, make sure you have it written down, because it is very pivotal for the rest of our unit. Okay, if you don't have that chart down, it's going to be very hard for you to remember things. So make sure you have that written down and it's kept somewhere safe. Okay, if you have any questions, let me know.